two types we can call as fast charger. Another is extreme fast charger. Do you have any idea about that? Fast charger and extreme fast charger. If you have any idea, please put it in chat box, or you can unmute and you can tell me. Any idea about fast charger? Okay. We have other types called fast charger. I will type here. One is fast charger. Another one is extreme fast charger. Or otherwise we can say ultra fast charger. Okay, is it clear? Can anyone tell what is the level of why we can call as fast charger or extreme fast charger? Any idea?
Output power is more, sir. More output power.
Yeah, very good. Output power in the range of any idea? See, we have already level 3. Okay. Level 3 is the maximum of 250 kilowatts or 150 to 200 kilowatts. More than 250 kilowatts, we can say the charger which is having the power rating of more than 250 kilowatts. Okay. What about the voltage rating and current rating? Automatically it is also raises, but voltage rating maximum of 500 to 600 voltage. Okay. Then what about the charging time? That is also very less than half an hour or 30 minutes. We can charge our vehicle. The SOC level of from 20 to 80%, less than half an hour. That is fast charger. Okay. This again we can say one of the charger called Jadamo, that we'll see later. But this we can't install in our own. There is separate organization is there, a company like ABB, Siemens, many companies are they are going to install. Even Tata also they taken in India. They are doing. Next comes to that is one type. Okay, is it clear? I think all of you. The voltage level is more than DC voltage level, especially DC. The fast charger and extreme fast charger, we are going to keep it in mind. DC charger level. Okay, the voltage level is up to 500 to 600 range. Extreme fast charger also more or less same. But the power rating, fast charger, it varies from 250 to 400 kilowatts. Okay, for fast charger. When it comes to extreme fast charger, what about the value? Again, the voltage levels maybe rises up to 750 kilovolt, 750 volt, and the power rating we can go 600. Okay, we can call it as extreme fast charger or flash type charger. How many of you have seen this news in? I think in YouTube also it came. Even many news channels like it came. ABB come out with one facility in France and Italy that is called TOSA, TOSA. That is the transport company which is present in the France and Italy. They have a separate like trolley car type. Okay, I think you might have seen in West Bengal, there is Kolkata, like tracks are there. The vehicles we can move like through small trains, trolley cars. It's called as trolley cars. They are going to use the same power supply, or sometimes each and every station they have extreme fast charger with more than 650 kilowatts or 600 kilowatts. It's like a flash type. We can charge less than 12 seconds, not in minutes. Less than 12 seconds we can charge the total bus transportation systems. Okay, like many advanced systems are there. Anyway, we will see one by one. Okay, these are all fast charger and extreme fast charger is somewhat high end, but anyway, I'll give the information in your classes. Okay. So that's what we discussed in previous class. Another one, the charging timings. How we are going to see that? Yeah, here another one um, slide. I think you are able to see here. See here, one slide is there. Here, as simple lead acid battery uh, charging time as well as the voltage, current levels. They are going to draw the graph. Okay. Normally, they used to go for starting constant current method. There is a red color line. Okay. And blue color line indicates the voltage profile or voltage levels of the battery. So the battery will be charged for around 70 to 80% with a constant bulk charge. Okay, high current charge will do. During the time, voltage will be somewhat increasing. So you know very well, it's simply Ohm's law only to behaves again. What happened if the current is kept constant, voltage will be slowly varying. Okay, with different resistance. The battery has own gas own resistance inside the battery. There is no physical resistance. So we have the electrodes and between we have separators, the battery. So all the things form a small resistance, which is very, very less. But it's that small resistance also plays major role in case of charging and discharging of batteries. Okay, after reaching this 70 percentage of battery SOC, we are going to keep voltage as constant, that is called absorbed charge, and the current will be quite obviously it will decrease. Then we go for another type equalizing charge, like a ripple charge. Here, the left hand side, I put different types of charging techniques you might have seen here. Okay, first two techniques are mostly used. Remaining types are used for to make the battery reach more than 95% and make it 100% ensure to make sure that the battery will be completely charged. Okay, then flow charge also one method, that is for whenever any process takes place, charging process takes place. What happens? There are a small chemical reactions will be there that leads to some bubbles inside the battery. That will be removed by means of applying positive and negative charges. Okay. So this graph indicates charging time and voltage and current with respect to lead acid battery. Likewise, lead acid, lithium ion, uh, sodium metal hydride, many types are there. All the batteries have their own these characteristics like time versus voltage and current. Okay, why we have to concentrate on this means depending upon this profile or characteristics, we are going to charge our battery. The timings you have to keep it in mind. Okay, various types of chargers. Already, according to the voltage levels, we have type 1, type 2, type 3, fast and extreme fast charge. Yes, up to this, I think all of you clear. Now, we have different topology or types of battery charger. Is it visible to all of you? Please, anyone respond? Yes. Anyone respond? Is it visible? My slide is
Yes,
visible
sir.
to
It's
all?
visible, sir.
Visible, sir.
So, so far I explained about the types of chargers. One minute. So, I think whatever I explained with respect to voltage levels. Next one is other battery charging classification or categorization is depends upon how this EVSE, what is called EVSE, electric vehicle supply equipment, how this equipment or charging infrastructure is available or present, whether it is in inside the car itself, all the conversions. I think these are a block diagram. I will explain one by one. All the equipments are components, electronic components and converters, everything will be present inside the vehicle means that type of charger is different. Or only thing we are going to take a DC voltage from the charging station, everything conversions, everything will be available in the charging infrastructure or charging station itself. That will be another type. Then another one, according to the connections, whether we are going to connect with the lines or cords, electrical cords or connectors. It may be conductive type or inductive type. That is wireless type we are having. Okay. So basically, by the first diagram in the top, it's nothing but a basic battery charging technology or block diagram. So we need a DC voltage for the battery, which is present in the car or vehicle. Okay, it may be any type, two-wheeler, three-wheeler, or four-wheeler. So we are going to take 60 hertz or 50 hertz supply from the grid or in the transformer, okay, which is connected to the grid lines. We are going to rectify to make the voltage into DC. And the ripples, of course, you know there are ripples are there that will be filtered with the help of filters. That is a capacitor or LC component. Then we get a pure DC here. That DC again, you may ask, here itself DC you get, you can directly connect to the battery. Why you are doing again another two process? Can anyone answer? There are two steps are there. Three steps are there. After rectification, we'll get DC. Our obviously we need only DC voltage. We can directly charge here. Okay, I'll come to the point. You have any high current or high power current handling systems. We must have isolation. Yes or not? Isolation is very very important. If you are not doing proper isolations, what will happen? Okay. What happened?
The system will fail you, sir.
System failure, that is second. Isolation, no, system will not failure. Handling of that equipment, it is very difficult, no? Isolation means what is the function of isolation? It prevents the shock. And another one, if any systems, any fault occurs in the secondary side or load side, it will disturb the source also, this side also, if you are not having proper isolation. Okay. Another one, we may have some sort of precautionary action we can take while handling the equipments. Okay, main thing is you said the system is damaged because of load side problem. That is also okay. Another one is handling. Isolations, we can easily uh, disconnect the system very faster. That is another one important aspect. You see here, whenever we are going to use this isolation transformer, it is not a normal transformer which we are used in our basic electrical lab. It is high frequency transformer. Okay, high frequency transformer. Then we'll get the signal of not a sinusoidal. It is like a square waveform. Okay, inverter. I think all of you know. You might have studied in your power training. Inverter. What is the function of inverter? It converts DC
Cannot
to
DC to AC, sir.
AC. So what happened here? There is a high frequency AC. It is not in the same 60 hertz signal. You might have done the experiment with 50 hertz conversion from the inverter. Okay, that is for you want to drive any appliance 50 hertz. But here, what they do, they are going to convert high frequency. Okay, high frequency means that why we are going to do high frequency means there is a direct relationship with that. That is inversely proportional to the transformer size. Okay, you may have the formula for EMF equation in case of transformers. Okay, 4 pi, 4.4 pi, no. The flux linkage, it depends upon the what is the transformer size, core area. So here, if you made the frequency higher, what happens? This transformer core size will be very, very less. Our total size of the transformer become very less. So this transformer is different from the whatever the transformer which we are used in electrical systems. Okay, this is very, very small size. Since we are going to use in where? Charging station. So here again, but what about the current rating will be higher? And again, this high frequency AC will be to get here because this is primary, this is secondary. Then again, we are going to put one rectifier, we'll get DC here. That DC will be given to the battery. This is what the basic operation of uh, a battery charging systems available. So here, both many what we can say, many usages are these transformers and all. Okay, but only thing it is not with normal or supply frequency 50 or 60 hertz. It operates in terms of kilohertz. Okay. Anyway, we'll see in detail diagram of this all the things. All of you know rectifier circuit. It may be basic diode rectifier. The inverter we can go for IGBT inverter. Here again we go for rectifier, diode rectifier. So we'll get the DC voltage here. That voltage will be fed to the battery, which is in the vehicle. This is a basic battery charging infrastructure block diagram. Again, I said two types. Onboard charger, I think you might have heard recent days. There are different two types, onboard charger and offboard charger. And in that again, we have conductive AC type, conductive DC type also is there. We'll see first one. Conductive AC charger power block diagram. I think you can see that. It is very simple how to classify onboard charger as well as offboard charger. See here, this is supply, okay, from the grid or from the any plug point which will be in a residential or office, wherever you are going to charge the vehicle. The plug point we are going to connect to directly grid lines through the supply. Okay, this part only we are going to have separate. Then all other components, whatever is there now for conversions, all power trans converters, everything will be present in the vehicle itself. There is a separate electronic circuit board or converter boards, everything will be there. Okay. Only thing we are going to fed AC here. AC supply, all the conversions, everything will take place inside the vehicle itself. And here how it is connected? By means of plus and minus, phase and neutral by physical wires like connectors. Okay. That's why it is called conductive type AC type. And this part we everything you can call as on board. Is it clear? Why it is called as on board? All the conversions or converters, everything will be available in the vehicle itself. Only thing power supply only we are taking from grid lines or in the where the electrical power supply available. If it is whatever I said, it may be low power supply or others can call level 1. Okay, type 1 charger. Okay. Next, come to the, I think it's clear to all of you what is meant by on-board and off-board at the same time conductive type. Conductive type means we are going to give physical connections between supply and to the converter which is present in the vehicle. Okay, that we can call as conductive type. On-board, every converters will be available in the vehicle itself. But what is the drawback? Anyone? So all the converters are available in the vehicle itself, and we can say it is as an onboard charger. It is quite good only, but what is the drawback? Any idea?
Space. It wants some high space.
Space is not a problem. You know, all power trans converter, how much its size? We need only maximum of 4, 8, 12 converter, 12 devices, then corresponding firing circuits. That's all. Maximum of we can go with 1 by 1 size, 1 feet by 1 feet. We can get all the converters in a single 1 feet by 1 feet. Okay. And size also very compact. Nowadays, you know, all the devices ratings are very less. What about the power rating? Are you able to increase power rating high value in this onboard charger? We have used it as different types, no? Level 1 or type 1, type 2. What is the drawback? Here, the power rating to handle that battery charger, it will be limited maximum to 1.9 kilowatts or 2.5 kilowatts. So the maximum just you can surf the net you can get. This is one kind of activity you can do. You have to take different types of EV vehicles, onboard charger, what are the voltage levels, okay, voltage levels, power levels, everything we have to classify. We'll do some case study on that. Okay, maximum 10 kilowatts. 10 kilowatts is very, very huge also because uh, while driving, what happened? This charger may get damaged also. This is the problem. Or while charging, that again the vehicle, those who are handling, the handling of the vehicle is very, very difficult. If you are going to touch any small insulation problem is there, automatically whatever huge shock or electrical shock we can experience. Okay, now I think some of the companies they come out with the robo for the charge connector. Because of this issue, they are using robo. Okay, high current it becomes very, very difficult to handle. Okay, so one problem is handling of high power in case of onboard charger is difficult. So that they will went for uh, other type called off-board charger. Okay, off-board charger you can see what are the voltage levels and power levels you need. Finally, we have DC voltage at this point. There is a dotted line is there, no? At this point, we can have okay all the conversions. Everything will be takes place in the off board. Off board means in the charging infrastructure. Just we are going to take this point plus minus DC power, and we can directly give to the battery which is present in vehicle. Here there are advantages as well as drawbacks also is there. Mostly a lot of advantages there. Rather than we can raise the rating. Okay. Yes or not? We can raise the power rating of the converters. We can go with even type 2 or type 3 level also. Yes, is it possible or not? Because everything will be not present in a vehicle. Vehicle just we are going to add this at this point only. This is plus minus. Okay, here we have a plug card. Again, the vehicle we have another line. We can have. Okay, is it clear? One minute. Sir, just Raju sir, 1 minute, sir.
Yes, sir. Yeah.
Okay.
Take your time.
So if you see that here, all the converters, everything will be available in not in a vehicle. It is in a charging infrastructure where we are going to provide. So we can raise. We can increase our power level, everything we can do that. Okay. Only thing, final DC power we are going to connect to the batteries. So this is one of the advisable, or we can say this method is used most of the places. Okay. But in case low power rating, we can go for onboard charger. Okay. Okay. With this, I am going to stop here. Raju sir will handle your sessions. Then in the meantime, by 3 o'clock, I will join. Okay. Sir, you can take, sir. I will stop sharing my content.
Focus. Right, right.
Madam, one நிமிஷம் join பண்ணுங்க.
Yeah, good afternoon, all of you. Hope you're all doing well. It's been a long time that I've handled a class again. How are you all? I get some response. Are you all doing well?
Fine, sir. Fine, sir.
Good, thank you.
Sir.
So tomorrow we'll be having an offline class, right? Will it be the first offline class for you, or you already had some offline classes?
Saturday we have. Yes, sir.
Saturday, last Saturday you had. Okay, do you remember what subject I was dealing? Any idea of what subject I was dealing with?
Battery algorithms.
Very good, battery algorithms. Okay. Why do we need algorithms for battery? Okay, battery algorithms, right? So, so in what way this subject is relevant to electric vehicles?
Sir, battery management. Yes, sir. Yes, sir.
Excellent. It is battery management system, right? We want a battery management system. What is a battery management system? What does it do? Okay, can use chat box also. Why do you use batteries in electric vehicle?
Sir, because it's the fuel of the
Yeah,
vehicle,
it is.
sir.
Very good. It is the
Another
fuel of the
use
vehicle.
batteries.
Right. Batteries acts like the fuel of the vehicle, right? So unlike the conventional vehicles where fuel is petrol, diesel, etc., in
Here we
electric
use
vehicles, the
batteries.
fuel is batteries. Okay. So what is a popular battery that we use in electric vehicle?
Lithium nickel.
Lithium ion battery. It is lithium ion battery.
Lithium ion
Right.
battery.
We use lithium ion battery. Right.
Yes, sir.
So we use lithium ion batteries in electric vehicle. Now, what will be the role of battery management system? Why do we need to actually go for a battery management system?
It monitors the batteries, the working condition of battery.
Very good. Very good. Excellent.
If it is damaged or is it
Yeah.
okay? Is it in perfect condition? The charging
Yes.
state of battery, the
Yes,
status of
yes.
battery.
Very good. So, battery management system, as your friend is rightly saying, Niklesh is rightly saying, battery management system manages the battery because the title itself says most of the terms we can understand from the English battery management system. Right, right. We know every cricket player or every what every film actor will have a manager. Why those people will have managers? Because their schedule is very busy. Unless they have a manager, their business will not work out. Right. In the same way, battery is also a very busy component in electric vehicle. Not just busy component in electric vehicle, but also battery is the costliest component in electric vehicle. If I take electric vehicle, almost 1/3 of the cost goes on battery. So it is very important for me to safeguard the battery, right? To properly utilize the battery, right? And see that the battery runs for longer lifetime, right? So otherwise, it is very difficult for me to sell the electric vehicle, right? Because if I sell electric vehicle and say that within 4 or 5 years, you have to replace battery with another cost of another 10 lakhs, no one is going to buy the electric vehicle. So it is very important for me to see that the battery life is extended, battery is safeguarded, right? And battery operates to its fullest performance extent. So that's the reason why we need to employ battery management system. Battery management system. So this course deals with what? This course deals with developing algorithms for battery management systems. Right. We may not be able to develop all the algorithms used for battery management system, but there is one specific requirement why we learn this course. There is one specific requirement for developing algorithms. Anyone remembers what is the purpose of developing algorithms here? Why which determine what will develop algorithms?
To know the battery status, sir. I mean, we cannot see personally, no, sir.
Excellent.
So
Right.
we
Right.
develop algorithms.
Very good. So
To monitor
one-
battery.
to monitor battery. So one important parameter which we need to measure is state of charge. What do you mean by state of charge? What do you mean by state of charge? Again, if you elaborate, you will know the meaning. State of charge. What does it mean?
The discharge and it's battery intaking outtaking of charge, sir.
So state
Battery
of
percentage.
charge. Yeah, battery percentage. Right. Good. What is, for example, all of you are using laptops or mobile phones right now. Now, can you tell me what is the status of your, what is the state of charge of your battery in in your laptop? Right. Everyone can see, right? Everyone can see what is the status of the battery. What does it indicate? What does it indicate? It indicates what is the present status of charge in the battery. How much charge still is hold? How much charge is still stored in the battery? Right. That is what state of charge is measured as. Right. So when I say that my laptop battery is still 80%, what does it mean? It means that still 80% of the charge is there to be depleted, or still we have 80% of the charge left out of the battery to use. Right. So that is what we call it as state of charge. So state of charge is a very important parameter in an electric vehicle because all the dashboard parameters. What do you mean by dashboard? I think all of you know it, right? Dashboard is dashboard in an electric vehicle or dashboard in any vehicle. Right, there will be a display board where you will be seeing with how much fuel is left, what speed we are going, what is acceleration, etc. So in the same way, electric vehicle also should have a dashboard. So in electric vehicle also the dashboard should display all these parameters: how much battery is still left, how many kilometers I can travel still, how much I can accelerate. All these parameters should be known to us. Otherwise, it is difficult for me to use electric vehicle. Right, right. So the same way, unless you have the fuel indicator in your conventional vehicle, right, it is difficult for us to use a conventional vehicle. Let us suppose your fuel indicator is not working. If your fuel indicator is not working, then it is very difficult for you, right? It is very difficult for you to use your vehicle. Right. So fuel indicator is just like our state of charge. How much energy is still left in the battery so that how many kilometers I can still travel? When should I get the battery charged? All this information is very important for me. Right. And also how fast I can accelerate, how fast I can decelerate. All these parameters are decided by are decided by a battery management system, and for that, state of charge is a very important parameter. Okay, so we were discussing about this in the last class. We were actually we were actually discussing about the role of this battery management system, and then so to determine the state of charge, we have techniques to determine state of charge, but the techniques which are used for laptop or mobile phones, they're all not sophisticated techniques. They're all inferior techniques which can be used for lower end applications. But for high end applications, I cannot use these techniques. I cannot use these techniques because in high end applications like electric vehicles or power grid applications or renewable energy applications or UPS applications where large capacity batteries are used, I cannot go for approximate estimation of state of charge. So it is very important for us to exactly estimate the state of charge. So that is the reason why you learn this course. In this course, you will be developing algorithms to determine the state of charge. And one problem with state of charge is that, what is the problem with state of charge? Why can't we directly determine the state of charge? Any idea? Unlike the other parameters, state of charge cannot be measured. It's not a physical entity which can be measured. So only thing we can do is we can estimate the state of charge. We cannot measure the state of charge. For example, voltage, we have instruments which can measure the voltage. Right, directly I can place a voltmeter and I can measure, or a sensor and I can measure the voltage. Similarly, current also can be done like that. Temperature also can be done like that. But when it comes to state of charge is not a parameter which can be measured. It cannot be measured directly. Okay. So it cannot be measured directly. We don't have an instrument which can measure the state of charge directly. So what we have to do is we have to go for estimation. Estimation. What do you mean by estimation? Estimation ante, what is English? What is the Telugu version of estimation? Estimation ante anchana, right? We have to estimate. We cannot say that I'll measure the state of charge. Rather, we'll say that we'll estimate the state of charge. Because there is no technique to directly measure state of charge. We can only estimate. Enta untundi and andaza vegaltam gaani, we will not be able to measure accurately the state of charge. So whenever this kind of estimation comes into picture, we will go for something called state estimation techniques. Like it is just an extension of your control system state space analysis. So we will extend the concepts of control systems, apply it here, right, and develop algorithms for state estimation. Apart from this, there are other estimation techniques like this artificial intelligence, machine learning techniques also can be used for state of charge estimation, because that is what we do. In all AI techniques or machine learning techniques, we go for predicting or estimating. So that can be done by using battery management. So this is a basic thing you are going to learn in this course, right? So I think already I have discussed it in detail. So we've already understood, I think, some parts of battery management system, right? So basically, if you remember, I think I was dealing with this part. So we've already dealt with this. Battery is basically formed with a cell. The fundamental element of any battery is a cell. Number of cells combined together will form a module. Number of modules combined together will form a battery pack. So battery pack is not just a single battery. It's not a single battery with positive and negative terminals. Battery pack is embedded, is having number of hierarchical components. At the lowest level, we have a cell. Number of cells combined together will form a module. Number of such modules combined together will form a battery. So we generally prefer modular structure because if there is any element going wrong, I can replace it with a similar kind of module. Right. Nowadays, everywhere, because it is easy for us to maintain, replace, etc. So that's the reason why we go for modular structure, because the same thing is repeating throughout the battery pack. So if something goes wrong, instead of stopping the entire battery pack, I'll just replace that module with another module and then get it repaired. So it becomes easy for me. So any of the cells are connected in series and parallel to meet the required voltage and current rating. So this is what we have discussed. I think we have already done this part. I think, and then we have seen that there is a problem. I think all this has been discussed. Cell balancing. The problem is that when we connect the cells in series and parallel, we connect the cells in series and parallel to meet the required voltage and current rating. Right. But when we connect them in series, what is the problem when we connect them in series? Can anyone answer? What happens when we connect them in series? What is the problem? Okay, let me ask a fundamental question. Which parameter remains constant in series? Which parameter remains constant in series? If I connect in series number of electrical components, which parameter will remain constant?
Current, sir.
Very good, current, right? So as this is this already done part, I think most of it is done, right? So when you connect them in series, the current will remain constant. So all these cells have to be charged. But when they are charging, what happens is, but because of their inherent nature, just like if I take, if I label all of you as third year, first semester, triple students, all of you will not perform in the same level, right? One cell will be charged faster, other cells will charge slower. So if one cell charges faster and reaches the rated voltage, other cells are still charging. What happens? Still the current remains the same. So what should happen now? The one which has charged to rated voltage now will be overcharged. Will be overcharged and it will get damaged. We should never exceed the rated value of voltage. If you're exceeding the rated value of voltage, it will get damaged. Right. So that is a problem. So while charging, we have to ensure that all the cells will be equally charged. And while discharging as well, all the cells should be equally discharged. Right. Otherwise, we will not be able to utilize the fullest extent of the cell. Mottam charging, we will not be able to utilize. So this is a problem we have. So we need to employ some techniques, charge balancing algorithms, to see that all the cells will charge equally and all the cells will discharge equally. And to do that again, state of charge can be measured at every instant of time. So state of charge becomes input for charge balancing algorithms. So that's the reason why we need to measure state of charge. Okay, estimate state of charge, in fact. Then I think you will be learning this CCCV method of charging the battery. You want to charge a battery. There is a technique called constant current, constant voltage method of charging a battery. Anyone heard this method? CCCV method of charging a battery. If you want to charge a battery, the first thing we need to have in our mind is we need to charge it as fast as possible, right? I cannot charge the battery slower because nowadays everyone is discussing about fast charging techniques. How can I charge a battery fast? Right, right. How can I charge the battery fast? Can you tell me technically what should be done if you want to charge the battery fast? What should be done to charge the battery fast? Any idea? If I want to pump more charge, what should I do? No idea. What is flow of charge called? What is flow of charge called? What is flow of charge?
Current, sir.
Yeah, flow of charge is nothing but current, right? Flow of charge is nothing but current. So if I want to charge the battery faster, I need to allow more amount of current to flow, large amount of current to flow through. So because now everyone wants fast charging techniques because already electric vehicles they are charging taking more time. So we want to reduce it as much as possible. This is the research area. How do you charge a battery faster? Right. Now Tesla claims that I can charge the battery within 15 minutes to 80% of its charge, state of charge. So now how is it done? So if you want to charge the battery faster, we need to pump very large amount of current. But we should ensure that this current will not exceed its rated value. Right. What is the permissible maximum limit of current? We should identify that permissible or allowable maximum limit of current, and we should allow so much amount of current to flow through so that the battery charges faster. But at certain point of time, what happens is as the battery is charging, its voltage also rises. When its voltage rises, at some point of time, the voltage also reaches the rated voltage value. So you can see T1 time. T1 time. At T1 time, the battery voltage reaches rated voltage value. If I continuously pump the same amount of current, what happens is battery voltage goes beyond rated voltage. When the voltage goes beyond rated voltage, always what happens if the voltage goes beyond rated voltage, it leads to thermal breakdown or insulation breakdown will happen and the device gets damaged or battery gets damaged. So we should stop at the point where it reaches rated voltage. After that, what we'll do is we'll maintain the constant voltage and the current slowly falls until the current falls almost to zero or 5 to 10% of this current. And if it is current is falling to zero, that means that it is almost reached to full charging. Right, it is reached to full charging. So this is called constant current and constant voltage charging method. So here you can see that if you want to employ this kind of charging algorithm, we need to consistently measure what is the voltage of the cell, what is the current through the cell, and also what is the temperature of the cell. So all these parameters need to be measured. And also we need to estimate the state of charge from time to time. So all these things have to be done and all these things can be done by using a battery management system. You understand? This is another role of battery management system. Then another, this, can anyone tell me what is this? What am I showing here? I think this part, did you started learning? What is this? What does it show? What does this show? What is this block diagram showing? Can you identify what are stage 1, stage 2, stage 3? Is the meeting still on or? Okay, what does this indicate? What does this indicate? What does this indicate?